here. I'm going to kind of talk through it from the beginning. I'm not going to rewrite everything that I wrote the first time. So you're given this triangle, two sides, and a non-included angle. And so this is the SSA, or the ambiguous case situation. And so we have to determine how many triangles are possible here. Is it 0, 1, or 2? Now I've sketched the picture. I tend to sketch the picture so that the given angle is at the lower left-hand vertex here, like this. And the two sides that are given are in these locations here, and so that the unknown side is horizontal and emanating from B towards the left, right. And then since the opposite side is smaller than the adjacent side, we know it's not case number 4. I mean, if the opposite side was bigger than 18, then it would be case number 4. It could only reach out here. There would be one triangle. Then I have height and compare. The height is going to be found by taking the adjacent side, 18, and multiplying by the sine of 35 degrees, which I know is a little bigger than 9. It's 10 point something, but it's close. It's less than 14. Sine of 30 degrees is 1/2. Sine of 35 is not far from 1/2. It's a little bigger, but multiply that times 18. It'll be something in the neighborhood of 9. So, but not more than 4, not more than 13. And so we have that the hypotenuse, I'm sorry, not the hypotenuse, the height is smaller than the opposite side, which is smaller than the adjacent side, and this is case number 3, which means there are two triangles that come out of this. So the two possible triangles that come out of this look like this, okay? So where this side goes off and hits the right of the height, like this. And then we're going to go solve that triangle using the law of cosines. The other one would be if this height, went, in fact, let me get rid of those dots. If it went over here and hit on this side of the height like this, that's where this other triangle is formed by looking at this part here. Okay, that's the green triangle on the right. One thing I pointed out, and I'll just reiterate here, is that this side is the same as this side in length, which means that this angle is the same as this angle. And since those two angles are the same, once I find angle C sub 1 down here, C sub 2 is this angle out over here. This is C sub 2. And so C sub 1, which is this angle, and this angle, is supplementary to C sub 2, meaning they add together to make 180. So I can just subtract C sub 1, this angle, from 180 to get C sub 2, which I'll do, which I did over here. I'm just recapping. Over the opposite 14 is equal to sine of C sub 1 over 1 and 35 over 14 after you do the algebra. And you get a little bit more than 47.5. From there, I'm going to subtract angle B, which was 35 degrees, and this angle C sub 1 that we just found from 30 degrees to get the 7.485. 5 look a little nicer. Once I have angle A, I find side lowercase a, which is 1. Again, using the law of sine, sine of 35 over 14 is the sine of the angle we just found over a sub 1. Do the arithmetic. I didn't have calculation here. Just plugging into a calculator, which you can do without my help. Pause it if you need to see it longer. So then now that I've solved the first triangle, I move on to the second triangle, and I go find angle C sub 2 first. As I said a moment ago, C sub 2 is supplementary to C sub 1, so I take 180 and subtract the angle C sub 1 that we found, and we get this 132.485. To find angle A sub 2, that's going to be 180 minus angle B minus angle C sub 2. and that's going to be, oh, I don't know. Let me go do the calculation. All right, having more technical difficulties. All right, so it's 1 minus 2, and then minus 35 also. So 12.51 degrees. And then once I have that, I just need to go find a sub 2, which I forgot to label, which is this little horizontal side length here, and up of sine's relationship, sine of 35 over 14 is 0.515 degrees over a sub 2. And so a sub 2 is going to be, and this is at least a number, 14 sine 12. And again, you can go run that through a calculator and get the number without my help. Most important technique is most important part of this is the technique. All right, so here's the next example. In triangle ABC, side B is 14, side C is 17, and the measure of angle C is 28 degrees. Solve the triangle. Now, ideally, you'll pause the video here and go try this on your own, see how far you can get, and then come back and watch how I solve it to see how you did on this one. All right, so like I said in setting this up, I would draw it in a way that puts the angle down over here. So that's that gets you used to the pattern that we're looking at. The side opposite is going to be 17 over here, which I don't know if it hits over here. That means the side adjacent is going to be 14. How do I know 17 was the opposite? Because it's angle C and side C. Those are opposites of each other. So that's why that's opposite there. So this is angle C. That means this is going to be angle A because opposite. This is B, so opposite of B is going to be angle B down over here, wherever. Now, this one should be pretty straightforward because we have the opposite side bigger than the adjacent side, okay? Opposite side greater than the adjacent side, which means this is number 4. And if it's case number 4, that means there's only one triangle on this, and it's straightforward law of sine of 28 degrees over 17 is equal to the sine of angle B over 14, and keep going. I don't think you really need my help with this, so I'll do another step. Actually, let me get rid of this and do B is the inverse sine of 14 sine 28 degrees over 17. And then once you have that, then you'll find angle A, which is A minus 28 minus angle B, and you get that. And then set up another law of sines to solve for the missing side A. Just in the interest of time, I'm going to move on and do a different example, because I think you could solve that without me. All right, now here's another example in triangle ABC. A is 8, B is 11, angle A 21 degrees, solve the triangle. So again, try to set it up in a consistent way that you can be successful and solve this over and over again. So here's the 8, here's the 11. This is angle A, that's side A, of course. Side B, so that means that this is C up here because angle B has to be opposite side B. And so opposite side is smaller than the adjacent, so I need to figure out the height. It's going to be J angle. And I figure that out, I'll be able to compare and see what's going on. So I don't have that already done. So it's 11 sine 21, which is 3.94 approximately. And so 8 is obviously bigger than that and smaller than the adjacent. And so there are two triangles formed. So 3.94 is smaller than 8, which is 7. This is the height. This is the adjacent side. And so we're talking about case number 3, two possibilities. All right, so we have possibility that hits over like this, and this is our 8, this is A, B. Or we have the possibility that it hits on the other side over here and looks like this. And let's call this C sub 1 and B sub 1, lowercase c sub 1 here. This is still A at 21 degrees. This is still 11. This is still 8. This will be B sub 2. This will be C sub 2. And this will be lowercase c sub 2 down here. So I just took this as a usual law of sines problem. Sine of 21 degrees over 8 is equal to the sine of B sub 1 over 11. So B sub 1 equal of 11 over 8. Let's go find out what that is. So we need inverse sine or arc sine. Divided by 8, which is 29.522 degrees. And so angle C sub 1 is going to be 180 minus A minus B sub 1, which will be approximately, let's see, so 180 minus 21 minus 29.521. C sub 2. Look at the wrong angle. So the sine of 21 degrees over 8 would be the sine of, this is in degrees here, 109.49 degrees over C sub 2. And so C sub 2 will be approximately equal to 8 sine of 129.479 over the sine of 21 degrees. Correctly, 17 point units, whatever they are. All right, let's go back up here now. For the second triangle, B sub 2, remember, is supplementary to B sub 1. So B sub 2 is going to be 180 minus B sub 1. So B sub 2 is going to be approximately equal to, so what's that going to be? 1 point, I think it's going to be 50.478 double minus 29.522, 150.478 degrees. Now angle C sub 2 is going to be a 180 minus A minus B sub 2.